In this video, we'll showcase how IBM Bob accelerates Instana deployments, simplifying installation, reducing effort, and helping you realize value faster. Let's begin with the installation of the Instana server. We're focusing on installing Standard Edition in a single-node cluster. The installation involves 3 steps. Step 1, File System Partition and Mounting, which we'll do manually. Step 2, Adding the Instana repository and installing the Stankel tool. Step 3, Deploying Instana. Steps 2 and 3 will be automated using IBM Bob. Let's start with Step 1. First, we run the lsblk command to see the available devices on the system. Next, we create the file systems. Then, we create the required directories. Now, we mount the file systems. We set the kernel parameters. And finally, we disable transparent huge pages permanently for optimal memory management. The file system is now ready for installation. Now, let's generate the scripts for steps 2 and 3 using Bob. We provide Bob with an initial prompt to generate the shell script for installing Instana. Since we've included the IBM documentation URLs, Bob opens them in its browser and reads the content directly. Bob has started creating the script based on the official documentation. Here's the generated script. Next, we give Bob another prompt to copy the exact commands from the IBM documentation. Bob updates the script accordingly. Now, we ask Bob to read the parameters from environment variables instead of prompting the user. Bob has updated the script, and it's ready to execute. Let's run the Bob-generated script on our Ubuntu VM. The script is executing, adding the repository, installing Stankel, and deploying Instana. The Instana server has been installed successfully. Now, let's access the Instana server backend UI. And there it is, the Instana dashboard is up and running. We've successfully deployed the Instana server by leveraging IBM Bob. Bob reduces manual engineering effort and ensures consistent, standardized environments. Teams don't need deep expertise to move fast, which significantly shortens product onboarding. Let's move on to installing the Instana agent and deploying the application for monitoring. The goal of this demo is to leverage Bob to generate the automation needed to provision an IBM Cloud Virtual Server Instance, or VSI. Install K3s on that server. Deploy a microservices-based logistics application. Deploy the Instana agent on the K3s cluster. And finally observe the application and tracing data in Instana. This is a practical example of how Bob can support end-to-end automation across Instana agent installation, application deployment, and observability. Now I open Bob and start with the first prompt. I ask Bob to generate a Terraform configuration that provisions an IBM Cloud Virtual Server instance and installs K3s on that instance. I also specify the required variables. I also clearly mention that all Terraform source files must be placed under Terraform folder. What Bob produces is a structured Terraform setup with variables, main resources, outputs, and example variable values. This gives me a ready-to-use baseline for provisioning the IBM Cloud environment and bootstrapping K3s automatically. Next, I ask Bob to generate an Ansible playbook to deploy the microservices-based logistics app. Bob then generates an Ansible playbook that applies the manifests in the correct order and supports deployment of the full application stack onto the K3s cluster. This saves time because I do not need to manually create a deployment sequence or write repetitive kubectl execution steps from scratch. After that, I use a third prompt to generate an Ansible playbook for deploying the Instana agent on the K3s cluster. Bob generates the playbook needed to deploy the Instana agent, including support for required deployment values and manifest handling. This completes the observability setup for the cluster. At this stage, the required Terraform and Ansible scripts have been generated. After making a few corrections and minor changes, I run the scripts using Bob or in the terminal separately. This is an important point for the demo. Bob dramatically reduces the effort required to create the automation, while still allowing an engineer to review, refine, and validate the generated output before execution. Now I switch to IBM Cloud and show that the virtual server instance has been created successfully. This confirms that the Terraform configuration generated with Bob has provisioned the infrastructure correctly and that the environment needed for K3s is now available. Next, I access the deployed application and briefly explain what it does. This is a microservices-based logistics application with multiple services working together to support business workflows such as authentication, order management, shipment handling, tracking, and AI-assisted capabilities. This part of the demo shows that Bob is not only useful for infrastructure generation, but also for helping automate real application deployment workflows. Next, I open the Instana UI and go to the Agents section. Here, I show that the K3s cluster is visible and that the Instana agent has been deployed successfully. This validates that the Ansible automation generated by Bob was able to extend the environment with observability capabilities. Finally, I go to the Agentic AI observability screen and show the tracing data. We can observe telemetry and tracing from the running environment. This completes the end-to-end story from automation generation to operational visibility. Bob accelerates Instana agent installation and application deployment by generating scripts quickly. It reduces manual engineering effort and ensures consistent, standardized environments. Teams don't need deep expertise to move fast, which shortens onboarding and delivery cycles. Bob supports end-to-end automation, from Instana agent installation to application deployment. Overall, it improves agility and allows senior engineers to focus on architecture while scaling delivery. Now let's see the demonstration of AI-driven observability and self-healing applications with IBM Bob and Instana. In this demonstration, we will showcase how we can leverage Bob for application development along with instrumentation and how efficiently Bob can reduce troubleshooting time and increase efficiency by using observability insights from Instana MCP server. Here, a microservices application is created and instrumented to monitor with Instana by IBM Bob. The architecture represents a library system application, where WebUI is the Node.js frontend component which forwards requests to backend components such as Books API and Users API, and a MongoDB database component, built with Python. When the application is deployed in platform like OpenShift, the Instana agent installed in the platform automatically monitors the running services and sends real-time metrics and traces to the Instana server at the backend. Using the Instana MCP server, Bob directly analyzes this observability insight to identify the issue and recommend remediation steps. The result is faster deployments, reduced mean time to detect and resolve issues, and a smarter, more resilient application lifecycle. Here is the microservices-based application generated using IBM Bob, along with the instrumentation required for Instana monitoring. With this, as soon as the application is deployed, Instana begins capturing performance metrics in real time. Instana MCP server is running locally in streamable HTTP mode on port 8080. The advanced mode, which is being used in Bob, is having access to MCP tools. In the settings, we can verify that Instana MCP server is running and all the tools available for various purposes such as analyzing infrastructure, managing applications, automation, and so on. To understand the microservices application components deployed and monitored by Instana, let's ask Bob, what are the services available in America's library system application? Bob makes use of appropriate MCP tools and fetches the results for our query. We can verify these deployed services in Application Dependency Graph in Instana UI. In the Application Summary page, we can view various out-of-the-box dashboards and ensure application is performing well with no erroneous calls, minimal latency, and various service metrics of the application. In the meantime, something went wrong and we can see a couple of warning and critical issue alerts on the application. One can switch the time window and understand since when the erroneous calls started appearing. Even in the application dependency graph, when switching time window to last 10 minutes, it becomes evident that calls from Books API and Users API components are not reaching MongoDB component and hence only 3 services of the application are being shown. Now, we can ask Bob to understand the erroneous call rate in last 1 minute time frame. After getting this metrics, we can ask it to analyze the root cause by checking Users API and Books API pod logs in the OpenShift cluster. Bob creates a quick to-do list for root cause analysis with tasks such as checking pod logs, analyzing the error patterns, and then coming up with the root cause analysis. By leveraging required OpenShift CLI commands, Bob fetches relevant application pod logs, analyses the error patterns and provides root cause analysis for the high erroneous call issue. According to the analysis, Users API and Books API components were not able to reach MongoDB component as there is issue with MongoDB authentication. Hence Bob suggests to update the MongoDB secret with appropriate password. As per recommendation, MongoDB authentication issue is fixed by the persona responsible for that, after which we can ask Bob to provide latest erroneous call rate in the application. We can also verify in the Instana UI that erroneous calls have stopped occurring now and also traffic is flowing between all 4 services of the application including MongoDB service. We have now seen how we can leverage IBM Bob for application development along with instrumentation and how efficiently Bob can reduce troubleshooting time and help in remediating issue quickly, using observability insights from Instana MCP server. Thanks for watching.